Hello YouTube, welcome back to Science While Gaming with me, Mr. S. This is actually round 2 of me trying to record these videos today because I managed to record 2 entire videos without having a microphone on. I'm human too, things happen. So, last time we talked about the periodic table and the importance of knowing the 3 major types of elements: metals, nonmetals, and metalloids. Today we discuss what to do with them. Elements on their own do quite a lot of things. You can build lots of stuff with them. Gold is super useful. Silver is great at conducting electricity. We know all of these things, but on their own, they're limited. So it takes combining together with other elements to create compounds. There are 2 major types of compounds that exist in the universe. These 2 major types of compounds are ionic compounds and covalent compounds. Ionic compounds are what we're going to focus on today. They are made of cations and anions. Now those 2 terms on their own just probably sound like nothing or nonsense, but they're really not. Cations are elements or groups of elements that have a positive charge overall, and anions are an element or group of elements that have a negative charge overall. When we're talking individual elements, we are talking about metals being cations and anions being nonmetals. Most of the nonmetals form anions, almost all of them. There's one notable exception to this rule statement as a rule, and that would be hydrogen. Hydrogen is not a metal, but it does form a cation. It forms a positive charge. It loses an electron in order to become positively charged overall. Excuse me. So that's an important thing to remember. So you have hydrogen forming positive ions, metals forming positive ions. Those are both cations. Nonmetals, except for hydrogen, they form negative ions. Those are called anions. That's their deal. The purpose of forming these ions is to react together to create actually your ionic compounds. And when you form an ionic compound, as indicated, they want ions, absolutely. They also want to have a neutral charge overall, and so when you form a plus, you form a minus, you combine with an equal number of the thing that you are. So you are positive, you form an equal number with the negatives. You form a negative, you form an equal number with the positives. So let's take, for example, something nice and easy, something that you guys have seen quite a lot in your life, no doubt. I am talking about sodium chloride. That's the scientific name for table salt. Table salt is an ionic compound. We have this combining with these 2 elements combining together to form a covalent compound. You have sodium, which has the symbol N, that almost looked nice, huh? Sodium, which forms N. Its symbol Na. It's a bit more like a Q, huh? Well, it's not perfect, and honestly, I'm not here to be perfect. So sodium combines with chlorine, which is C with a lowercase l. These 2 things combine together to form your salt, what you're used to having at your dinner table. Sodium is a metal. It forms a positive charge, specifically +1. Chlorine is a nonmetal. It forms a -1 charge. And you can indicate that with either a single plus or a single minus, or if you wanted to put like a 1 here, you can do that, or a 1 here, you could do that. So you could write Na plus 1, or Na1 plus, or just Na plus. The same thing for chlorines. When you're writing the ions, you always want to indicate the charge. Now, sodium chloride as a compound is these two things combined together, but when you write them together, you do not write your charges. You only write NaCl. Now, how many NAs and how many Cls depends on our charges. Since we know that they each only bring 1 to the table, I only need 1 of each to do that. So I only need 1 of each thing to bond together. But if we were to join this Na with, let's say, oxygen, it's just O. Oxygen brings a -2 to the table. Sodium still brings a -1. So to balance them out, we'd need to have a little 2 down here, which I'm not going to attempt to draw. There's not enough space, and you see what I'm working with here. So you'd need 2 of these NAs, so you'd write Na2O. Writing the formulas is fairly easy once you know the charges, which is a thing that you can get from your periodic tables. The only charge that you can't get from your periodic table would be your polyatomic ions. Now, not all polyatomic ions. No, all polyatomic ions are able to be looked up. You can look up the formula and charge for every single one. That's kind of their deal. And it makes life easy that you can look them up. You don't have to memorize them. As a teacher, as a person, if you're a professional in the industry, no one's going to ask you to memorize your polyatomic ions, especially if you're working in the industry, because you can simply look them up. They'll have resources for you to use. Your teachers have resources for you to use them. You have Google. It's a thing. So why not take advantage of the things that you have available to you? It makes sense. It is what it is. So not having to memorize them is super easy. What you do need to memorize and learn and know is how to name these compounds. Ionic compounds are named in 3 to 4 easy steps. Okay, you take any ionic compound, and let's go ahead and take our sodium, our Na. That's a terrible looking A. I regret it already. A. O. So we're going to look at that sodium combined with the oxygen. Okay. Now the proper formula includes a 2 down here. I know it looks more like a Z, but use your imagination. It's a 2. So you got a 2. Na2O. That's sodium combined with oxygen. But what do we call this? Because you can't just say it's sodium combined with oxygen. With the ions, we know that they always form balances. We know that Na brings a +1, oxygen brings a -2, so the formula itself is pretty easy, but it needs to have a name, because how exhausting is it to refer to something by, oh, you have a sodium combining with an oxygen. You have an iron combining with a fluorine. Like, that's a lot. So this molecule as a whole needs a name. The way we name it is this. First thing you're going to do, identify the metal that's here. This metal, sodium. Then you just write the name of the metal. Step 1 is write the name of the metal. Whatever's here in this spot, the first thing that's written, if it's a metal, write its name. If it's a polyatomic ion, a group of elements that make an ion, write the name of that thing. That's easy. There's only going to be one polyatomic that's going to be in this first group here. Really, for the most part, there are several, but 90% of them you're just dealing with one. It's called ammonia. That's the one that'll be in the front, so we're just going to write sodium here. So we write sodium. Then we have the O. That O on your periodic table is oxygen. What do you do with the oxygen? Well, you just write oxygen, and then you chop the end off and change it to IDE. So it becomes oxide. So we have sodium oxide. If you had a polyatomic here in this second part, you're going to simply write the name of the polyatomic. It's that straightforward. Step 1, write the name of the metal. Step 2, write the name of the non-metal. Or, if you prefer, write the name of the cation first, and then write the name of the anion second. Done. No more thinking. Problem solved. Over. There's one more scenario that exists that we have to deal with, and it deals with iron. Well, not just iron. It deals with metals that are in the middle of the periodic table. That middle part of the periodic table is called the transition metals. These transition metals have, that's the wrong term. These transition metals have what's known as variable charges, so they don't always have to form plus. Na always forms +2. My little pig is attacking a giant spider thing here. That's fun. Na, as we talked about, always forms a +1. That's what it gets every single time. You can even mark it on your periodic table that Na always forms +1 because it always forms +1. Given that we know Na always forms +1, it's very easy to combine it together with things. Iron doesn't always form +1. Copper doesn't always form +1. Lead doesn't always form +1. So we need to know what charge these things are going to have. And so when you write the name of that, all you have to do is, in between your cation and your anion, you write the charge of that cation in Roman numerals. So if it's iron 2 combining with oxygen, you'd write iron, parentheses, Roman numeral 2, and then oxide. And that's it. The formula aspect wouldn't be affected by this process. You'd have iron, which is Fe, combining with oxygen, and if it's Fe2, as in iron 2 oxide, it's going to look like this. This is the formula. There's no 2 down here because that 2 in the middle of iron 2 oxide tells me that iron is bringing a +2, okay, and oxygen, we know, always brings a -2. Every time. Brings a -2. The iron's bringing a +2. That was a terrible 2, but it's bringing a +2 because it says 2 in the name. So when you have a transition metal, you have to write the charge of that transition metal in the name as Roman numerals in between your cation and your anion. Those are your basic rules. The basic idea of what you're doing for every ionic compound is just that. Step 1, write the name of the cation. Step 2, write the name of the anion. Step 3, if your cation is a transition metal, write Roman numerals to indicate the charge in between the cation and the anion. Those are your steps. That's it. That's all we got. If you are doing anything else, then you're overthinking it. Really, it can boil down basically to just that. The hardest part is knowing your charges, which comes from knowing your periodic table, from remembering the things that you've covered before in classes. If you have a polyatomic, it comes from looking up the polyatomic. It's not hard to look up the polyatomic. All you have to do is just Google it. Short answer, Google it. Why not? Google is a resource for you to use. Why not use it? As long as you're not using it to cheat on a test, I see no moral question about why you can't simply Google a question. That's what it's there for. You won't always have a teacher, you won't always have someone who knows, so you go to the internet as a resource to find something that knows. If you have any questions, or if you want to practice writing polyatomics or ionic compounds, and you want to actually see some, be like, hey, how do I do this thing? You can ask. I'll leave you some in the comments. If you leave a comment asking, I'll give you a couple of ionic compounds right there in the comment box, so that way you can name them, and if you name them properly, I'll let you know. If you don't, I'll tell you that too. If you mess up and don't name them correctly, I'll tell you. Why wouldn't I tell you? All you gotta do is ask. Thanks for listening. There'll be a follow-up video about naming the other type of compound that elements create when they react together, the other type known as covalent compounds. It'll be a follow-up that'll come shortly after this one. Again, if you have any questions, thanks for watching. Drop a line, comment, whatever. You know where to find me. Have a great day. Bye, YouTube.